This is a solution video for PFA4 strategy guide. Before I get started, I want to alert you to this. Do not just look at the answers in this video without trying to do the work yourself. You will not learn much, and it's a waste of your time, for real. Don't bother watching this video if you're not doing some practice yourself. Practicing the annotation is the only way you will get this. So let's look at this one to start off with. We know that two places connected by a wire show the same pressure, meaning voltage. Trace wires to annotate HML pressure or values with units of volts. Take a moment and try to do this one yourself using this clue. Pause the video. You can use these notes as a guide. And now that you have tried to solve this problem yourself, I can show you how I would do it. Trace wires to annotate pressure looks like this. I start at this side of the battery, and any two places that are connected by a wire show the same pressure. So basically, like, any place along that wire is going to be high, high, and high. The most important place to annotate is right here on the wire next to the bulb. You'll see why in a second. But I'm not done yet, actually, because there's more parts of the circuit that are connected. I'm still tracing those wires that can be connected back to the H side of the battery, so that has to be H also. I can do the same thing with the low side of the battery. Any two places connected by a wire show the same pressure, so tracing these wires out, I can tell that that has to be low because it's connected directly back to the low side of the battery. This is a pretty simple version of a circuit, but it can get more complicated. So I'm going to show you some more complicated examples. Down here, I'm not going to do the whole thing for you, but I want to point out this hint. Look for more than one bulb on the same path. When bulbs are on the same path, the total PD, in this case 6 volts, the difference between these two sides of the battery is 6, divides equally among the bulbs. So let's try doing some annotation here. I'm going to start with this, and I'm going to trace wires that are connected back to the 6 volt side of the battery. I know that this has to be 6 volts and this has to be 6 volts because they're both connected back to the 6 volt side. Same thing on this side. Now I know that has to be 0 volts, and this is connected too, so that would have to be 0 volts. Now I have to stop, given what I know so far, because all of these other places aren't directly connected to the 6 volt or the 0 volt side of the battery. This is where this hint comes in. When bulbs are on the same path, the total PD divides equally among the bulbs. So I can tell there's one path here through 3 different bulbs. I can tell that the total PD is divided equally. So 6 volts divided among 3 bulbs means 2 volts across each bulb. That means that there is a 2 volt difference across this bulb, and I'll have to look for a number that's 2 away from 6. What number is 2 away from 6? It's got to be 4 volts, and because this is 4 volts, that has to be 4 volts too, because two places connected by a wire have to show the same value. I'm not going to finish this. I'm going to let you finish this one, figure out what that number has to be, and then you can check it by asking somebody else. Similarly with this one up here, try your best. Use this idea that the total PD across this path that has 2 bulbs on it has to be divided equally in order to figure out what that value has to be in the middle. I do want to do one of these down here because I think it's helpful to see a more complicated example. On this one, I would start with the low side and I'd say, all right, 2 places connected by a wire, show low pressure, low pressure, low voltage, low voltage. They have to be exactly the same because they're connected by a wire. That's as far as I can go without crossing a bulb, so I'll move on to the high side of the battery and I'll trace it out. That has to be high voltage. This has to be high voltage because it's also connected, but this also has to be high voltage because it's also connected. This has to be high because it's also connected. This has to be high. Any places that are connected back to the high voltage side of the battery get that same H. Now, I have some things here that I can't figure out, but this is where I would use this hint because I can see that there are 2 bulbs on one path. This high to low difference gets divided equally. So that's where I would use this M to explain why these bulbs are lighting up a little dimmer than the others. So that would go from H to M, and this would go from M to L. Now, objective 3 on the test is about predicting bulb brightness. You always have to annotate first and then do your prediction. So, for example, up here, now that I've annotated this, I can say, how can I use this difference to predict bulb brightness? Now, 6 volts is kind of like an H. 0 volts is kind of like an L, and 4 volts would be kind of in between. So it would be like, okay, 2 volts, 4 volts, and then 3 volts would be right in the middle. I can tell that this high difference would result in a very bright bulb. Essentially, if I put my finger on one side of the bulb on this chart, and put my other finger on the other side of the bulb on this chart, the distance between my fingers tells me how bright the bulb is going to be, tells me how different those numbers are. So this would have to be very, very bright because 6 volt difference is a large difference. This bulb here, I would put my finger on 6 and my finger on 4. That is a much smaller difference. My fingers are not very far apart. So this would be only a little bit bright. So I'm drawing my lines to show it's not nearly as bright as this bulb down here. If I do that same thing to this example, I could say, okay, H to M, that is not very bright. My fingers aren't very far apart. M to L, exactly the same brightness. Not very bright, so I could go like this and this. However, H to L would have to be really bright because H to L is a big difference. This bulb, however, shows 0 difference across it. I could put one finger on H and another finger on H, and there's no difference between my fingers, so this bulb does not light up. The key to passing is to annotate circuits. On paper, on the screen, whatever works, just don't skip the annotation or I promise you'll make mistakes. There's a bunch more problems here to practice with, so take the opportunity to practice the rest of these problems. You may need to refer to DCC 3 to learn more about current. These arrows are also important, and I'm not talking about them here in this video, but DCC 3 does a good job of talking about them.